All right, welcome. Today, we're pulling back the curtain on artificial intelligence to look at something we don't often see, the very real infrastructure and the very real consequences that power the AI that's literally reshaping our world. I mean, think about it. It's in the apps on our phones. It's in the algorithms that help run our cities. AI is just woven into our daily lives now. It feels totally invisible, you know, almost like magic. But here's the thing. It's not magic. Not at all. Every single time you use an AI, every image it generates, every single line of code, it's all powered by a massive, and I mean rapidly growing, physical footprint. We're talking about these gigantic buildings called data centers. And that brings us to the big question for today's explainer. What is the real, tangible price of this AI revolution? Because it's a cost we have to measure not just in dollars and cents, but in energy, in water, and ultimately in waste. So let's start with the most immediate cost, and that is a truly staggering demand for electricity. Just take a look at these numbers. Back in 2022, data centers worldwide used about 460 terawatt hours of energy. Okay, fast forward to 2026, that number is projected to more than double to over 1,000 terawatt hours. This isn't just steady growth, folks. This is an explosion. And AI, it's the fuse that lit the whole thing. And if you're trying to wrap your head around what 1,000 terawatt hours even means, here's some perspective for you. It's enough electricity to power the entire country of Japan for a full year. That really makes the scale of this demand hit home, right? So where's all that power going? Well, this chart breaks it down for us. The servers, the actual brains of the operation, they take the biggest slice of the pie at 60%. But look at that next piece. A massive 35% is dedicated just to cooling systems. It's basically a giant air conditioner to stop these incredibly powerful machines from literally melting down. Now, this massive energy demand isn't some abstract problem that only tech companies have to worry about. Oh no. It has a direct and, frankly, an increasingly noticeable impact on your household electricity bill. So how does that even happen? Well, it's this mechanism that some call cost shifting. Here's the play-by-play. Utilities have to spend billions building out new power plants and grid infrastructure to serve these huge data centers. But the way the rules are set up now, they spread those costs across their entire customer base. The bottom line here is that regular people, you and me, we end up subsidizing the power grid for some of the richest companies on the entire planet. And believe me, this isn't just a theory. Look at these projected numbers for areas with a lot of data centers. We're talking about a 13% surge in bills in Virginia, an extra $18 a month in Maryland, and a 16% year-over-year jump in Illinois. These are real dollars coming out of real family budgets. This financial strain is getting so serious, it's actually boiling over into politics. It became such a hot-button issue that it was a central theme in Virginia's 2025 governor's race. The winning candidate basically ran and won on a promise to stop this indirect subsidy and make tech pay its own way. Okay, so how on earth are we supposed to meet this absolutely insatiable demand for power? Well, right now the US is in an all-out energy scramble, and it's using a really complex and sometimes kind of contradictory strategy to do it. And this slide really shows you the core dilemma. On the one hand, natural gas is the workhorse. It's supplying over 40% of data center energy because it's reliable and you can bring it online pretty quickly. But on the other hand, there's this massive build-out of renewables. Solar generation in Texas, for example, is set to nearly double in just 2 years to try and keep up. But honestly, the most surprising part of this whole story might be the revival of nuclear power. Tech giants are desperate for carbon-free energy that runs 24/7. So they're funding the restart of old plants like 3 Mile Island. They're pouring money into these next-gen small modular reactors. And get this, there are even proposals to repurpose nuclear reactors from retired Navy aircraft carriers. Wild. Of course, this energy scramble comes with a really heavy environmental price tag. It's creating some pretty significant and often hidden consequences for our most basic resources: the air we breathe and the water we drink. Let's start with carbon. By 2026, data centers in the US are on track to pump out over 105 million metric tons of CO2 every single year. This is a direct result of relying on fossil fuels for more than half their electricity, and it pretty much undermines a lot of those corporate climate pledges we hear about. And it's not just CO2. Data centers are creating what some people are starting to call digital smog. Locally, they had these massive diesel backup generators that they test every month, and they spew out all this dangerous particulate matter. And then, on a regional level, their constant demand keeps older, dirtier power plants running, which contributes to really serious public health issues, sometimes in communities that are nowhere near the actual data center. And the thirst for water? It's just as astonishing. All those AI-generated images and chatbot conversations require an immense amount of cooling. A single large AI data center can guzzle up to 5 million gallons of water every single day. That is the same amount of water used by a town of 50,000 people. You can imagine the strain that puts on water supplies, especially in places that are already prone to drought. And what's in that water really matters. The most advanced high-performance computer systems use these next-gen liquid cooling solutions. The problem is, they can contain something called PFAS, which you might know as forever chemicals. These are toxic compounds that just don't break down in the environment, and they're being linked to really severe health problems as they start to seep into our groundwater. And finally, we have to talk about what happens when all this cutting-edge technology gets old and obsolete, because what we're facing is a legitimate tidal wave of electronic waste. This timeline shows a really frightening path. In 2023, AI generated a few thousand tons of specific e-waste. But because the hardware gets replaced so quickly, that number is accelerating dramatically. Projections are showing a cumulative total of up to 5 million tons by the year 2030. So why so much waste? Well, the intense race for AI dominance means that this powerful hardware, like GPUs, which are basically the engines of AI, they become obsolete in just 2 to 5 years. And this discarded equipment is just packed with toxic heavy metals that can poison soil and water. Geopolitics can even make the problem worse by restricting access to the most efficient hardware and forcing companies to use older tech. Which brings us right back to our central question. The promise of artificial intelligence is immense. It really does offer a future that could be truly revolutionary. But, as we've just seen, it comes with a steep, very tangible price. The question that we all really need to start asking ourselves is, are we prepared to pay it?